Identifying Performance Issues, Part 1 of 2. It's one thing for a user to tell us, hey, my system is running slowly. Or frankly, you as a systems administrator who wants a new server added to your server closet to try to convince your boss of the same thing. Hey, we have some performance issues here. Typically, both help desk personnel as well as IT decision managers want some raw data to back up those claims. Moreover, as DST's troubleshooting systems, we need to be able to visualize the performance of a system to actually get a handle on what's going on under the hood. To that end, we're going to begin this nugget by reconsidering the event logs, in particular the system and application logs in Event Viewer, and in the demo associated with this nugget, we're going to go off in a related and hopefully interesting direction by looking at how to attach event log data to tasks in Task Scheduler, and I'll actually demo event forwarding. We touched on that a few nuggets ago. You'll actually see how it works in this particular nugget. Next, we'll look at services. What services are, how to get at them, how to change their startup type, best practices for troubleshooting them, and then we'll complete by looking at the continually revamped Performance Monitor. Now, the difference between PerfMon and XP and Vista was huge. Hopefully, you're already familiar with the Performance Monitor in Vista a little bit, because the ramp up from Vista to Windows 7 is nowhere near as big as the gap in functionality between XP and Vista. However, even if you are making the transition directly from XP to Windows 7, by the end of this nugget and demo, you should be nice and comfortable. Let's get rockin' and rollin'. System and application logs. Now, why do you think Microsoft singles out these two Windows event logs in particular when we're looking at system performance? Well, remember that the system log is where the operating system itself writes its information warning and error messages. The application log contains, again, the same general classifications, information, warning, and error, but this time for your first and third-party applications. First being Microsoft, ones that come with Windows or that you've installed. Third being software supplied by other vendors. Consequently, it is crucial that we understand specifically how to search those logs, and even more importantly, quite frankly, how to understand the message data that's contained within those log entries. As a systems administrator, you want to, I would imagine, tweak and customize event log behavior on one or more of your workstations. If you're in a super small network, maybe you have a couple of dozen workstations, and you can set the event log parameters, stuff like retention, maximum log file size, the save location, all that on a PC by PC basis. However, really, we don't want to do that kind of thing, because whenever you're messing with individual workstations, you're unnecessarily duplicating effort, and of course you're introducing human error, the great possibility of making a mistake on one or more of those PCs. Consequently, we have group policy to the rescue that enables us to tweak just about all metadata aspects of the event log service in Windows 7. And you'll see that in the upcoming demo. I'll show you where to go in group policy to find those policy options. We introduced forwarded events in an earlier nugget. Remember what that is where you have one or more source computers, in this case and in this context, Windows 7 boxes, forwarding a predefined filter of their log data. You generally speaking never want to capture all data and send it over. You want to keep it simple in order to preserve network bandwidth and to increase your troubleshooting efficiency. And you're forwarding that data to a collector computer. Couple services under the hood, and we're going to talk about services in detail in just a few minutes. We have the Windows Event Collector service that needs to be running on the machine that's receiving those forwarded events, and we also have the WinRM or Windows Remote Management service that needs to be running on your sources. Take-home message, forwarded events make it a lot easier for you as a support technician to keep your eye on events happening on multiple workstations. I think I also mentioned a few nuggets ago that Microsoft has an enterprise tool that this kind of thing, event forwarding, is a core part of its functionality. That's called System Center Configuration Manager 2000. 2007. And there's actually another System Center product, System Center Operations Manager 2007. That's where you can get into large-scale management. I do want to add a little asterisk or a parenthesis to this, that forwarded events are cool, but this technology, generally speaking, doesn't scale very well. You're going to have a hard time managing this if you get beyond just, I would say, 10 or more computers forwarding events. If you have that case where you want to do more large-scale event forwarding and filtering, you'll want to look at the Microsoft System Center line of enterprise software. A third technology that you're likely to see on your exam, actually, Microsoft seems to want to make sure that all of their Microsoft certified professionals in Windows Vista and Windows 7 know about this, is the interrelationship between the event viewer and the task scheduler utility. Yet another quantum leap, really, in functionality, going from XP to Vista and then to a much lesser degree from Vista to 7, is the Windows Task Scheduler. If you've used it in Vista, you already know it's an extremely powerful tool for watching events and firing off activities when events happen, or just to put processes and scripts on a schedule. Well, the interrelationship here is you can attach a task to an entire log, or more commonly, you can attach a task to a specific log entry. Maybe in your security log, a particular failure event, maybe if you're looking for logon failures. And when you do that, you're able to do one of three things whenever that event fires off on that local computer. You can send an SMTP email, you can display a simple message box on the local machine, which is a little bit weak in most cases. Email is much more robust because you can receive the message wherever you are in the world, provided you have access to your email box. And the third thing you can do, also very powerful, is that you can automatically run a program or a script. We'll look at this in the demo. Excellent, excellent feature. We have already talked about custom views, especially now in Windows 7, where we have not just the built-in logs, the standard Windows logs, but we also have the application and service log collection. There's so much data there right out of the box. Custom views are cool because we can customize what we're seeing and see only the log entries that make sense for our troubleshooting scenario. Finally, there's the crucial question. Okay, I know how to get into logging, I know how to set it up, I know how to do filters. However, I'm reading these log entries and they might as well be written in Mandarin, and I don't speak Mandarin. Okay? Therefore, is there help available? Of course, everybody's friend Google or Bing are available, your major search engines, but there's at least two sites that I want to make you aware of that are devoted specifically to helping you understand what certain event IDs mean. And as a desktop support technician, this is really useful information for you, I promise. First, there's eventid.net. This used to be an excellent site. The reason why I no longer call it a full-scale excellent site that I enthusiastically recommend is that it's gone to a subscription model. It used to be completely open and free, but now it costs money. What is still free is the Microsoft TechNet Events and Error Center website. You definitely want to find this site and bookmark it. In fact, here it is right here, the Microsoft TechNet Events and Errors Message Center. And basically what you have here in the main search interface is a number of drop-down list boxes that you can just drill through the product, say Windows operating system, and then you can look at a particular OS like Windows Server 2008, and you can pass in event IDs, event source, message text. I find it interesting that as of this recording in February 2010, we do not have an entry for Windows 7. However, Windows Vista is certainly close enough. The product version for Windows Vista is 6.0. Windows Server 2008 is represented, however, and you can just drill in from there. For Windows 7 errors, you can use this guy over here to search for the product name, event source, event ID, however you want to handle it. Vista Application Error 10001. Okay, so we've taken a look at troubleshooting using Event Viewer and parsing the system and application logs. Now let's take a look at services, what they are, how they work, and some of the gotchas in systems administration and desktop troubleshooting. I enjoyed the definition of a Windows service so well from wikipedia.org that with citation I'm including it on this whiteboard. Let's take a look at it together. Wikipedia says on Microsoft Windows OSs, a Windows service is a long-running executable that performs specific functions and which is designed not to require user intervention. That's crucial. The great succinct explanation. So a service is typically a background process, many of which are configured to start up automatically every time the machine starts up, performs a specific service, and generally, like I said, runs in the background and the user doesn't interact with the service directly. Windows services can be configured to start when the operating system is booted and run in the background as long as Windows is running, or they can be started manually when required. They are similar in concept to the Unix daemon. You might have seen that term before, D-A-E-M-O-N, daemon or daemon. I tend to use daemon. Same idea. Now, of course, Windows ships with a whole bunch of services, and then as you add additional applications, you may get more. The more services you have running, the bigger your RAM footprint, and consequently, potentially, the slower your system performance. So the idea here is we want to practice an IT management strategy called least service. Similar to least privilege, which we'll talk about in just a minute. Least service means you should disable any services that are not required on that system. That has two benefits. One, of course, is performance, as I said, because you're lowering the CPU cycles that the operating system needs to expend in daily operation, and you're also lowering the RAM footprint, the committed RAM in use. The second benefit to least service is security. You're enhancing security because you're reducing the attack surface of that machine. Many Windows services support remote connectivity or network connectivity and therefore can possibly be compromised by a malicious user or a hacker. If we disable the service, then we're in effect closing the door to those kind of exploits and attacks. A site I want you to be aware of, this is not an exam tip, this is just a professional tip between you and me, is the Black Viper website. This is at blackviper.com, and I found it to be extremely helpful. The person or people who run this site seem to do their research quite well. The main thing I do at this site is check out their suggested service configurations. You'll notice they have several versions of Windows covered, including where I'll go right now, Windows 7 service configurations. And the main body that I tend to look at is the table where they give you an alphabetized list. Notice all these are hyperlinked so you can read more about what each built-in service does. He or she, I don't know who the owner is covering only those services that ship with the product. The actual registry service name, this is important if you're going to manage the service from the command line. You can use, for instance, net stop and then the registry service name to stop the service, or net start service name to start the service. Gives you the default depending upon the edition of Windows. And then if we scroll over, it's probably hard for you to see, so let me highlight this row. They have a safe option, a tweaked option, and a bare bones option. So they've done testing to figure out which services tend to break functionality, so you would make your choices from there. There are plenty of sites out there that help you understand what Windows services are. I just simply have gotten a lot of mileage out of Black Viper's site over the past several years. Now, all services run in a particular security context. This is called the service account. And with Windows services, at the least, they tend to run in the context of the identity called system. And this is a built-in identity that represents the operating system. Obviously a pretty highly privileged account. However, it's not network aware. Some network aware services run under the context of a network service where the operating system has greater privilege to go out onto the network. You may need to tweak the service account such that instead of using a built-in system identity, you use a local Windows account, or more likely for a network aware application, a domain user account. And you want to apply here not least service but least privilege. For instance, I'll give you an example. You install SQL Server 2008 on one of your servers, or potentially you install SQL Express Edition on a workstation. You're going to need to run the SQL Server Engine service in the context of a service account. And especially if that SQL Server is doing network communications. After all, isn't that what SQL Server is all about? Many administrators, I'm not going to say many, I'll just say some, will be conservative, say, well, in order to make sure this product doesn't run into any permissions problems on the network as the service is running, I'm going to use a domain administrator account. Generally speaking, a very bad idea indeed. Least privilege means we want our service account, if we are using a domain identity, to have the minimum rights on the network required for that service to operate. If you over-privilege a service account and a malicious user compromises that identity, although service accounts are generally not used for logon, you can actually log on using a service account if it's a local or domain user account. Well, then that malicious user is operating in a superior context, and we want to avoid that. Tools for managing services. 2 of these 3 are built into Windows 7. we have Task Manager, gives us real-time service information, however in a read-only view. If we want to stop services, pause services, restart them, we can open the Administrative Tools folder on Windows 7 and launch the Services Microsoft Management Console. Several different ways we can get to that actually. Services is part of the computer management built-in console as well. I always recommend that you go to Microsoft.com, look up and download the sysinternals tool called Process Explorer. This gives you a run of all the currently running processes and services and gives you far more detail than what you get with either Task Manager or the Services MMC. There's another sysinternals application that I absolutely recommend with the highest praise, and that's called Auto Runs. That in particular is helpful because it shows you everything, and I mean everything, that's configured to start automatically when your system boots. Auto Runs and Process Explorer are just simple exes, so you can put them on a thumb drive and carry them with you to different workstations. Finally, we have Startup Type. As I said, services that are going to be used by the OS or by your installed applications for, well, in perpetuity, I guess, as long as the application or OS is installed, would have a startup type of automatic. However, if you're cutting back on your services and the principle of least services, you can either disable or set them to manual. I'm going to repeat this in the upcoming demo, but you want to be conservative here. I tend to start by setting the startup type to manual, which means that the service is off by default, but if the service is invoked by another service, maybe a dependent service or another application or the OS, then the service can start up. Now the downside to that is if you have a malware infection, a Trojan horse software that's running as a service, you set it to manual. Well, elsewhere in the registry, that malicious software may start up the service of its own accord, you see? So therefore, you've got disabled as a possibility, and this means no other service or application, including the operating system, will attempt to start that service. You also want to check, and we're going to definitely go into detail on this when we cover malicious software, the run keys in the Windows registry, both for the local user hive as well as the local machine hive, to just get another view on the processes that are scheduled to start during each system boot up. I realize you're probably hungry to see some of these technologies in living color. Hang on just a minute. We're going to do the demo. We just have to get through one more whiteboard here, and that is doing performance tuning and troubleshooting with the built-in Performance Monitor tool. Now, Performance Monitor is excellent for establishing what's called a system baseline, and a baseline is a representation of system performance over time. You can look at it kind of like this. Hopefully, ideally, we want our baseline to be flat, but the idea of a baseline, as I said, is over time, over hours, days, weeks, whatever your baseline period is, you want to capture both the peaks and the valleys in system performance to get a realistic outlay of what that system's capable of. Once you record your baseline data, you want to archive that, and then in the future when you're troubleshooting performance problems, you can run another baseline and compare those new settings to what the original baseline was. So the crucial importance of the baseline is that it gives us a frame of reference for evaluating system performance. The four main subsystems involved in a performance baseline are, pretty logically, the processor, the memory, the disk, and the network subsystems. Of course, we have some overlap, especially when we think of memory and disk. Memory and disk counters and objects overlap because, as you know, there's physical RAM as well as virtual RAM, otherwise called the paging file or the swap file. So we want to keep that in mind as well. Also with Performance Monitor, we have the question of real-time versus logged data. On the real-time front, there's the Performance Monitor itself, as well as a related tool new in Windows 7, I'll show it to you in the demo, called Resource Monitor. It's more or less a dashboard of system performance. Downside with real-time is that it's not being logged or permanently stored. In Windows Vista and Windows 7, the manifestation of logged data is called the Data Collector Set, or DCS. Really robust way to log data. Hang on to your hats for the demo. Finally, and this is an exam alert, so I'll throw an asterisk up here, we have the issue of local versus remote monitoring. Here's the setup. Let's say you want to monitor a Windows Server 2008 box, and then you have your administrative workstation over here. I was going to say V for Vista, but let's be current and say it's a Windows 7 domain member. Are you going to load up Performance Monitor here on the server and load those counters and objects locally, or are you going to fire fire up perfmon on your administrative workstation, set up the counters and objects locally, but have them being derived remotely from a target machine? Well, the correct answer here is the second. We want to do as much performance monitoring remotely as possible. Any idea on why you think that is? The reason for this is that we don't want to skew our performance statistics, our baseline data. If we're actually running the data collector set locally on the target that's being monitored, you're generating noise or overhead just in the processing of that data. Therefore, if we offload all of that and simply derive our statistics from the target machine, we can get a much more realistic picture of system performance. That's the deal. In our long-awaited demonstration, we're going to show the technologies that we discussed over the previous several minutes. We'll lead off with event logging, paying particular attention to the interaction of Event Viewer with the task scheduler, and we'll also look at event subscriptions or event forwarding. Then we'll turn our attention to managing services in Windows 7 with an eye toward troubleshooting, and then we'll finish with Performance Monitor, looking at real-time as well as logged baseline data. In this demo, we're going to be ping-ponging in between WinNugget, our Windows 7 domain member workstation, and DC Nugget 2, which is our Windows Server 2008 R2 edition domain controller. We're going to begin with a discussion of Event Viewer. We'll call this Event Viewer Redux because, of course, we did cover Event Viewer in a previous Nugget. If you're exposing the administrative tools off the Start menu, we can get to Event Viewer there, of course. Alternatively, we could do a Windows R and type Event VWR to open up the Event Viewer MMC console. I myself am a big fan of opening up consoles by using command line options. Now we're going to be careful not to cover ground that we've already trodden in previous nuggets. So therefore I'm going to focus on some features of Event Viewer that you're likely to see on your certification exams and really are just nifty in general. The first is the notion of attaching a task scheduler task to events. For instance, you might be monitoring one or more of the Windows logs, perhaps the application log on a particular workstation, and you want to receive, say, an email message automatically whenever that particular event ID, as you see I'm pointing to this information message for defrag, say event ID 258, is raised. Alternatively, another example of this neat integration in between Event Viewer and the task scheduler is we could automatically kick off some program, script file, or process if a particular event shows up in the log. Without further ado, let's go ahead and attach a task to a log entry now. Easiest way to do this is to find a representation of that particular event. In this case, I'm randomly selecting this event ID 258. We'll right-click and select Attach Task to this event. You can give the task a name. I'll just call it Event ID 258. And then on raising this event, send an email message. When we click Next, we see that this information is already populated, application log, defrag source, event ID 258. And what you need to remember for your lives and your certification success are the possible actions that we can take when we integrate the task scheduler with Event Viewer. You can start a program, you can send an email message, or you can simply display a message pop-up. I'm going to choose send an email here, and then we won't go through the rest of this. You get the general idea. We specify all of the addressing, subject, body, and possibly attachment for that message. And of course, we need a Simple Mail Transfer Protocol or SMTP server in order to actually send the mail. If we choose the Start a Program option, we simply browse out to either an executable program file, or it could be a script, a PowerShell script, for instance, or a VB script. Or we can display a message, which is a simple message box that has the window title and then the message body. So that's all there is to it. You can actually right-click an entire log to attach a task to the log in general. That's kind of a broad spectrum way to go, but I think you get the general idea. Next thing we're going to cover is event forwarding. We talked about this in the earlier nugget. Now I'm going to actually buzz through how to do it. Let's assume that our Windows Server 2008 box, DC Nugget 2, is going to be the event collector, and the WinNugget computer is the forwarding source. On the forwarding source, all we need to do is open up an elevated command prompt. You know how to do this by now for sure. And we need to set up Windows Remote Management Service. And we can do this either from the Services console, but the most efficient way really is to just type WinRM. And in fact, before I use the quick config flag, let's use the question mark. Tells us that Windows Remote Management RM is the Microsoft implementation of, this is an industry standard, WS management protocol, provides a secure way to communicate with local and remote computers using web services. It's nice that Microsoft is adopting some open standards, wouldn't you agree? So WinRM quick config tells us that currently WinRM is not set up to receive requests on this machine. The following changes must be made. Start the service with delayed auto start and then actually start the service. I'm going to hit Y here to make these changes. Alright, WinRM has been updated for remote management, and it tells us we created a WinRM listener on HTTP star to accept WinMan requests to this machine. So we have an HTTP listener. Remember, WinRM operates using Hypertext Transfer Protocol, and this is integrated with Windows Firewall. An exception for WinRM is automatically enabled. You might find a failure when you run WinRM quick config if there's a time skew between the client computer and your domain controller, or in particular, your PDC emulator. So you can always synchronize the time by using W32TM. That is the current tool that we use to manage the Windows time service in Windows 7 and Windows Server 2008. It used to be that we would use the net time command. That's been deprecated. Now it's W32TM. Now we'll mosey on over to DC Nugget 2, our domain controller, and open up an administrative prompt here. Here we already have on the server side the Windows Remote Management Protocol enabled, so we don't have to run that command, but we do need to set up the Windows Event Collector service. Command line interface to that is appropriately enough called wecutil. There's a QC flag for that sets the startup mode to this service to delayed start. We're going to click Y and exit. Final step is on our collecting computer. We'll open up Event Viewer. I'll close out of my Actions pane here to give us some more room to work with. And in the Subscriptions node, we'll right-click and choose Create Subscription. Subscription name, I'm going to call this AppLog Win Nugget. The destination log by default, as I've discussed in the previous nugget, or actually a prior nugget, is the forwarded events folder, but you can change that if you'd rather store those forwarded events in another spot. Subscription type, you've got a choice here between collector initiated, in other words, it's kind of a pull request on the part of the server, or you can do source computer initiated, where you can create groups of computers that are managed either through group policy or local configuration to push their entries to the collector. In our case, we're just going to add the domain computer, WinNugget. Make sure it's in here. You can test the connectivity. Succeeded, which is really nice. And then we'll click OK. Final thing we need to do to complete the subscription is to determine which events we want to collect from that source. In the name of preserving network bandwidth as well as your management, you want to be very parsimonious and careful which events you choose. I'm going to open Select Events and choose Edit to bring up this filter. And this dialog box looks identical to when you're just creating a regular view filter in Event Viewer. We could say events logged in a certain time period. We can grab everything or just warnings. I'm going to grab warnings, informations, and errors. We're going to do this not by source, but you can pick and choose which log. This is going to be the application log in this case. You want to grab all event IDs or perhaps a comma-separated or hyphen-separated list. We can look for keywords, events associated with a particular user or computer. I think we've got the basic idea again, so we'll click OK and then OK. So now we see in our subscriptions node, we have one active subscription, collector initiated, one source computer, and it tells us where the forwarded events are. If we right-click, we can delete, we can come back to properties and customize what we're filtering and where it's being filtered. We can disable, retry, and finally from the right-click menu or shortcut menu, we can check the runtime status. You definitely want to do this and make sure that the status is active. If you get a failure here, the most common problem I've seen is unknown username, bad password, and how to fix that is to visit the properties of the subscription, come down to Advanced, and make sure that the account is credentialed that has at least read access to the source logs. Defaults here to machine account, so you'll want to put specific click user and then add a domain administrator account here and verify the password by clicking user and password there. After that, it's just a case of coming on over to the forwarded events log and waiting for events to show up. Here we are back on WinNugget, generating some event log activity, and what you're seeing here is a simple message box that says search service started up. Now what the heck is going on there? Well, what happened there is in Event Viewer, I found a representative event. This one is the search service started. I figured this was a good candidate, and I right-clicked and I attached a task to that event such that it would fire off a simple message box whenever the search service is started. Now, once you attach a task scheduler task to an event viewer event or a log in general, you'll notice there's not a place in here to actually get to those tasks again. So you have to open up from your administrative tools folder the task scheduler utility. And in there you'll find a folder called Event Viewer Tasks. And here is our task. I just let the default name happen here, so it's not very user-friendly. And on event ID 1003, it displays a simple message box. So I just wanted to complete that process for you. And now to flip over to DC Nugget one more time, we see that some events are starting to trickle in slowly from our source computer. We received an information message dealing with the event forwarder service, and this, of course, if we look at the computer field, is coming from WinNugget. So we've done our proof of concept and demonstrate that that works. Very final thing I want to show you with the event viewer stuff is switching back to WinNugget, where you can get to these options to control event log behavior in group policy. I'm just going to do this in the group policy editor, the local group policy editor on WinNugget. That's gpedit.msc. And if we navigate to the path Computer Configuration, Administrative Templates, Windows Components, we have an event log service node that contains separate group policies for each of the 4 built-in default logs. And notice that the policies are pretty much the same. You can customize log file path, maximum log size, backup log automatically when full, log security access, and then a policy for retaining old events. So this is what you would do as a domain administrator. You'd set this in a domain level group policy to customize event log metadata for all affected computers. There's also an event viewer category as well as an event forwarding category where you can tweak intervals and resource usage parameters. So much for that. Now let's consider services and the management of those services thereof. I'm going to right-click these tasks and close them just to clear the decks. One place to look at services, of course, is Task Manager. If we right-click the taskbar and select Task Manager from the shortcut menu, it invokes this tool. You can also use my favorite keyboard shortcut if you'd like, Control-Shift-Escape. What some folks do, and I consider this kind of the ultra long way around, is to press Control-Alt-Delete and then get into Task Manager there, but frankly I wouldn't recommend that. The difference between an application and a processes run in the background hidden, at least in most cases. Sometimes you may have, say, in this case, VBox Tray is obviously a notification area icon, and if we actually fire up a real live process, for instance, let me fire up PowerPoint and minimize the application, we will see now we have a foreground application, a user-invoked application, Microsoft PowerPoint, and its status. And then in our processes list, in this case, we have powerpnt.exe. Your other processes, of course, are here and provides a more granular way to knock down a program. Sometimes if a user has a hung-up application, you're not able to successfully end the task just by trying to close the foreground application. Sometimes you'll want to come to the process tree, select the root process, or at least what you think is the root process, and select either end process or end process tree, which kills not only that process, but any processes on which it's dependent. Of course, we're concerned with services specifically, and in the Windows 7 Task Manager, we have a really nice way to quick sort those services. Admittedly, this is a read-only view, but it can be helpful to see what's on the computer in terms of services, what the current run state of that service is, etc. If you do want to make changes, notice that there's an Administrator Protected Services button. that'll open up the actual Service Control Manager application, which we can get to also by opening a run prompt and typing services.msc or by using the Administrative Tools folder. Cool. If we open up the Services console, we have again, by default, an alphabetized list of these services along with a description. We can quick sort to see what's been started and what hasn't. We can quick sort to look at different startup types. To change the parameters of a service, we can double click it. Here's where we can modify startup type, automatic delayed start, regular automatic, manual, or disabled. If you're wondering whether to disable a service that you don't think you need, then I would suggest you go with manual first. Manual allows the operating system to start the service if it needs to, or if a foreground application or another service needs that one, it can start it. Be careful with disabled because you might actually inadvertently prevent functionality on that system. We can start, stop, pause, and resume, and then this is particularly important from a security standpoint. The Logon tab will default to the local operating system in most cases, but especially for line of business applications, you might want to select a local or domain user account, or at least an account that has the least privilege necessary to run that process. Something that's overlooked, I think, by many Windows administrators is this recovery option, where you can specify to automatically attempt to restart the service one, twice, or every time the service fails. So please know that. You can actually configure programs or scripts to run at failure as well. And then finally, you can quickly see what other services either are dependent upon the current service. So fax is dependent upon print spooler, and print spooler in turn depends upon remote procedure call and HTTP. Good and good. When troubleshooting users' computers, definitely a good idea to look for, well, a couple things. Let me find one that's been added after the fact. You'll want to look at the path to executable. This used to be called image path, and I think that confused a lot of administrators who weren't developers. Path to executable is important because especially for perhaps malicious software, we're going to cover this in greater detail later in the course, of course, is that if we know specifically where the service resides in the file system, we can boot into safe mode and delete the file, or perhaps just rename it now, and then when we restart, the file will not start automatically. You know how that pesky malicious software works. The final couple things I want to say about services for now are, one, definitely consider downloading Process Explorer, which puts the Services console on steroids. Actually, it kind of puts the Task Manager on steroids. We have to remember that Task Manager is not a logged utility, it's a real-time utility, gives us live data. The Performance Monitors tool is cool because instead of just seeing these generic taskhost.exes that are in effect bundles of your running services, we can actually break those down and see specifically which service are associated with which instance of task host or service host. Alright, let's close out a PowerPoint and finish this demonstration by looking at the Performance Monitor console. Again, we'll visit Administrative Tools in Windows 7 and select Performance Monitor. As we've already talked about, Performance Monitor includes both real-time, that's the Performance Monitor console proper, and logged, those are the data collector sets, methods for establishing a baseline for system performance. Now, if we select the root node here at Performance, you're going to see something new here in Windows 7 called the Resource Meter. The way Microsoft set up the Performance Monitor in Windows Vista is that they gave you the Resource Meter here on the Performance homepage. I like how they cleaned this up. You get basically a text-based system summary of the main subsystem counters like memory, network interface, physical disk, and processor. Used to be kind of overwhelming in Windows Vista to look here. This isn't obvious, so check this out. We can either click this little icon here, or we can choose Open Resource Monitor, and this actually opens up those real live data tools in a separate application. We can look at the overview for the four subsystems, CPU, disk, network, memory, with associated services. So it's just another way of looking at the same data. On the right, we can look at large, medium, or small views, pictorial views of that real-time data on those subsystems. If this overview tab is information overload, of course, we can look at each subsystem specifically. Microsoft did a particularly good job, in my opinion, of demonstrating things that used to be kind of non-intuitive. For instance, in Task Manager, Performance tab, Again, if you're not a developer, you may not be sure what commit charge and kernel memory versus physical memory and those things are. Systems administrators will be more comfortable with this interface here, where it just says right now I'm using 50% or so of my physical memory, and we actually see the split here between what's in use, what's standby, and what's free. We have our disk activity by process. All this stuff is eminently sortable. And then we have our network utilization. So much for Resource Monitor. That's pretty cool. Performance Monitor proper, if you've used the perfmon in previous versions of Windows, it's the same basic deal here. You'll note that Microsoft gives you just a single counter instead of 3 by default. If we want to add new counters, we can click the plus sign. And as I mentioned in the whiteboard, when you're doing real live performance monitoring, it's a much better idea to do this remotely. So instead of looking at the local computer, you'd want to browse out and bring in a remote system. So I'm at WinNugget, but I've now shifted my focus in Performance Monitor to DC Nugget 2. And then we can just drill through, find particular counters with which we're interested, determine whether there's an instance for that object. For instance, if we had a multi-core or multi-processor system, we can look at processor statistics on a processor-by-processor basis, or we can just look at a weighted total. Show description has been around since the earliest days of Windows NT, gives you a little blurb on what that's used for. Click OK, and you've got yourself some more data. We can change the graph type. This has been a long historical feature of Performance Monitor, the line chart, the histogram bar, or my favorite, frankly, since I'm colorblind, the report view. Finally, the deal with data collector sets. It's beyond our scope to go into these in a great deal, but I do want to just give you the briefest of overview for these. Data collector sets are a much more robust way to log data than what we had with, say, Windows Server 2003. You'll remember we had the counter log and the alert possibilities there. Here, data collector set, we'll just look at some of these built-in ones, system diagnostics and system performance. System performance is a little bit easier to look at. You have different types of objects that you can add to your log. The performance counter object gives you the full access to all of your objects, counters, and instances from Performance Monitor. That's pretty easy to understand. Traces log occurrences of predefined events. Trace, in my experience, is used primarily by application developers. And then finally, you can add what are called configuration data. And here is where you can map or record changes to registry keys or Windows Management Instrumentation, WMI, paths, etc. So the idea with the data collector set is it gives you much greater possibilities to do a well-rounded system capture. And another neat thing about data collector sets is that you can import and export their definitions. To view the data, they get stored down here in these really nicely formatted reports. Identifying Performance Issues, Part 1 of 2 review. In this nugget, we examined methods for putting our fingers on the proverbial pulse of a Windows 7 system performance. We revisited the idea of the system and application logs and some of the neat additional features that are supported by Event Viewer. We then defined a service, so we understand what that is. That's a concept that'll recur elsewhere in this training for sure. We also looked at how to troubleshoot those services. And then we completed this nugget by discussing the Performance Monitor tool, a bit on its evolution from previous versions of Windows, and how we can use it to generate real-time as well as log statistics. I hope that this has been informative for you, and I'd like to thank you for viewing.